Welcome one and all to the lesson on the graphs of sine and cosine, where here you will learn to determine the period and phase shifts of the functions themselves. Here's a recap on the standard form of both the sine and cosine functions, where there are 4 different components in each form, and 2 of them is the primary focus of this video, where b and h helps you find the period length. Now the b itself is not the period, but it does affect it, and we'll learn what the period means, and h is the horizontal or phase shift, which tells you how the graph moves left or right. Here's a recap on the basic sine function. Again, please remember that you will always start from the origin 0, 0 to find the first critical key point. Goes up to high 1, mid 0, low -1, mid 0. And that is one complete cycle. Here's a recap on the standard form and the domain and range. Here's a recap on the basic cosine function, where the cosine function starts at 1 up here and then drops down twice and then goes back up twice. So that's the shape that it would make if it was a complete cycle of a cosine function. Then the standard form is there, domain range is also there. So now let's talk about the period. Now the period itself is the length of the cycle. So tying it back with the unit circle is 1 complete revolution is 360 degrees or 2 pi, and that 2 pi cycle shows up on the graph in this form like this. So the part that I have shaded in blue is 1 cycle out of this entire sine wave or graph. And notice that, again, we start at the origin 0, 0, we go up to high 1, mid 0, low -1, mid 0 again. So that is an important note to take, that the period should have 5 key points. So graphically, all you visually have to do is just find where it starts in the middle, at the y-axis right here, and then find the 5 critical key point, and when you get to your 5th one, the x value is your period length, so it's 2 pi. So the period is 2 pi in this example. Now if you don't have a graph given to you, but you have an equation, then there is a formula to find the period. And the formula is 2 pi divided by b. So b is the number directly in front of the group x plus or minus h. So once you know what b is, then you just go ahead and put it in this formula, and that will find you the period length. Now we're going to do a couple examples focusing primarily on the graphs though. So here's a graph. I've already gone ahead and identified that this point is where I start from here. This is the next point that it goes through mid. This is the lowest point. This is the next midpoint, and then this is the highest point up here. So the total length is going to be 2 pi. So my period is 2 pi. So if I took my line just right here just to reaffirm it, and there you go. So that's 1 complete cycle through 2 pi. And then if I moved it over here, if I had moved it over here, it would be the same thing. Here's my second example. So this one starts midway through. So visually speaking, I can assume that this is sine, which there's no guarantee. But I know that if it starts here mid, it has to go up high, then mid, then low, then mid. So you should see that it kind of alternates as you're going through it. And on the 5th one is when you stop. So this total length is from 0 to 2 pi over 3. So the period is 2 pi over 3. There you go. Kind of confirm that over there. So again, notice how it alternates. High, mid, low, mid, high. And it just cycles through. Now the last thing we'll talk about is the phase shift or the horizontal shift, which literally focuses primarily on the left or the right transformation. How does it move? Now due to the sine and cosine graphs being very similar, it is going to be harder to determine which function you're dealing with just by giving the graph alone. So the main focus will be on the equations. Now the big thing you need to remember is that the h value and the either positive for the left transformation, and if it's negative it goes to the right side. And don't forget that these h values are based off the x values, and we're primarily using radians. So that's why I don't expect the h to just be regular numbers. It'll be in the form of like pi. So here's our first example where we have y equals sine the group of x minus pi. So that just means that visually, or just by looking at it, I already know that this is going to go to the right, and it's going to go to the right pi. So how does that work? How does it visually make sense? Well, here's a graph that I drew for the sine function. Again, sign starts in the middle of the graph, mid, then high, then mid, then low, then mid. But if I'm shifting pi, what I'm going to do is I'm going to move this entire graph. I'm going to keep the axis the same. I'm going to move it. My first critical point, key point, is going to start at pi now. So this will be my new graph. And there you go. Now notice the dip. You would think kind of just by looking at it, you would say there's no difference in it. Well, think about this. The original starts at mid, then goes high. But if I shift it to the right pi over, now if I look back at the origin, this next point goes down low, then back to mid. So it kind of switched the order of the critical key points. But that's why it's good to start with the original first, then you shift it to whatever number it is after you find the critical key points. And notice that the critical key points are still the same. It makes that same alternative move. That's one complete cycle. But again, that's all you have to do to identify that the graph shifted right pi. Now this one is cosine x plus pi over 2. So I can just say by looking at it that it shifted left pi over 2. Okay? So if I go to my graph, again, you can assume that these intervals, like in the previous example, are already laid out for you. So what you do is first is identify the critical key points. This is cosine, so it's going to start high, then mid, then low, then mid, then high. Well, I shifted to the left pi over 2, so that just means that I move it to the left to negative pi over 2 over there, and this is now going to be my new graph after it shifted left pi over 2. And that's all there is to it. At a future point, you will learn now how to compile all these different components in the standard form, and now you can try to draw the graph, or vice versa. Given the graph or given the pieces of information, you can write the equation.